In this video, we want to learn about Rational Zero Theorem. What is Rational Zero Theorem? Based on Rational Zero Theorem, we know that for a polynomial, possible rational zeros are in the form of factors of the constant term over the factors of leading coefficient. At first, it seems a little confusing. Let me explain the Rational Zero Theorem by an example. Consider this polynomial x to the 3 plus 6x to the 2 plus 11x plus 6. The constant term of this polynomial is 6, and the leading coefficient, the coefficient of x to the 3, is 1. So, based on the Rational Zero Theorem, the possible rational zeros, the numbers that make this polynomial equal to 0, are in the form of, so possible rational zeros are in the form of factors of the constant. What is the factors of 6? Plus minus 1, plus minus 2, plus minus 3, plus minus 6. What is the factors of leading coefficient, which is 1? Plus minus 1. Very simple. Now consider all the combinations of numerator over denominator. Because dividing by 1 or negative 1 doesn't change anything except sign, so possible rational zeros for this particular polynomial are only plus minus 1, plus minus 2, plus minus 3, plus minus 6. So, based on the Rational Zero Theorem, we know that if we set this equal to 0, and we look for value of x, the only possible zeros for the answer are in this list. And basically, let me write down here for you the factored form of this given polynomial here. If we factor this polynomial, it would be in the form of x plus 1 times x plus 2 times x plus 3. If we set this equal to 0, then the answer would be x plus 1 equals 0, the x would be negative 1. From setting x plus 2 equals to 0, x would be negative 2. From setting the other bracket equal to 0, x would be negative 3. As you can see, these numbers are all in our list that we have here. So, we expected to get some of these numbers in our answers, and exactly we got some of those numbers. Now you should be a little familiar with Rational Zero Theorem. Let me show you some more examples and a little more complicated. Look at this polynomial, 4x to the 4 minus 4x to the 3 minus 25x to the 2 plus x plus 6. Based on the Rational Zero Theorem, we know that the possible rational zeros for this polynomial are in the form of plus minus 1, plus minus 2, plus minus 3, plus minus 6, because the constant term is 6. Now look at the leading coefficient is 4. List all the possible factors of 4. Plus minus 1, plus minus 2, plus minus 4. These are the only factors for 4. Now consider all the combination of numerator over denominator. If we divide these numbers by 1, it doesn't change anything. It's same numbers. So finally, for possible rational zeros, we have plus minus 1, plus minus 2, plus minus 3, this is 2, plus minus 6. But if we divide numerator by 2, we have 1 over 2 and negative 1 over 2. So we have these extra rational numbers, plus minus 1/2. Also, we have 1 from numerator over 4, so we have plus minus 1 over 4. Then if we consider 2 from numerator over denominator, 2 over 1 is 2, we have in our list. 2 over 2 is 1, we have in our list. 2 over 4 is 1/2, we have in our list. What about 3? 3 over 1 is 3, 3 over 2 is 3 over 2 is new. So we add 3 over 2 to our list. 3 over 4 is also new, so 3 over 4 should be added to our list. What about 6? 6 over 1 is 6, we have in our list. 6 over 2 is 3, we have 3, and 6 over 4 is 3 over 2, we have in our list. This list includes all possible rational zeros for this polynomial. The only possible zeros, rational zeros, attention, not all zeros, the only possible rational zeros for this polynomial are in this list, nothing beyond this list. But which numbers are actual solution, actual zeros? If we write the factored form of this polynomial, it would be this expression: 2x plus 1 times by 2x minus 1 times by x plus 2 times by x minus 3. And if we set this equal to 0, from this we get x equals negative 1/2. From the other one we get x equal 1/2. From here we get x equal negative 2. And from this x equals 3. And as you can see, all of these numbers are in or possible zeros. So always the numbers that we get by setting polynomial equal 0 is in the list of rational zeros. And don't worry how we factor the polynomial, how I write this right away. I will show you this in the next examples. Our focus here is in understanding the rational zero theorem. Our focus here is not on how to factor polynomials. If you want to learn more about how to factor polynomials, watch my video for that topic. And I will show you some examples for that. But right now, we want to learn rational zero theorem, nothing else. What about next example? X to the 4 minus 11x to the 2 plus 18. Focus on this example. There is something new here in this example. The constant term of this polynomial is 18. The leading coefficient of x to the 4 is 1. So the possible rational zeros, so possible rational zeros for this polynomial are plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 9, and plus minus 18. 18 all over plus minus 1, because leading coefficient is 1. So possible rational zeros are the numerator numbers, because divide by 1 doesn't change anything. And if we factor this polynomial, this can be written as x to the 2 minus 2 times x to the 2 minus 9, because 9 times 2 is 18, negative 9 plus negative 2 is negative 11, and it can be written in this form. For x to the 2 minus 2, we can write it as x minus radical 2 times x plus radical 2, x minus 3 times x plus 3. If we set this equal to 0, from this we get radical 2. From setting this equal to 0, we get negative radical 2 for x, 3, and negative 3. Maybe you wonder, these two numbers were in our list, plus minus 3. But why these numbers are not in our list? The answer is because these roots, these zeros that makes this expression equal to 0 are not rational numbers. Rational numbers tells you the possible rational zeros are in this list. But radical 2 is not a rational number. Negative radical 2 is not a rational number. So that's the reason these are not in the list of possible rational zeros. And again, let me repeat this here. Our focus here is not on factoring, the method of factoring a polynomial, is on learning the rational zero theorem. And as you can see, these roots that here we have are in our list here, because these are rational zeros. Attention, 3 is 3 over 1. Negative 3 is negative 3 over 1. So these can be considered as rational numbers. And so these are in our list. Now you should be familiar with rational zero theorem. List all possible rational zeros based on rational zero theorem, and then determine the actual solutions. Here we are going to see what are rational zeros, possible rational zeros, and I will show you how to factor this polynomial fully. Let's start. Leading coefficient is 2, constant term is 9, so possible rational zeros are are plus minus 1, plus minus 3, plus minus 9. These are the factors of 9. The leading coefficient is 2, plus minus 1, plus minus 2. So our list would be these numbers. If we divide numerator by 1, it's the same, plus minus 1, plus minus 3, plus minus 9. But if we divide them by 2, we have 3 over 2 and 1 over 2, which are new, and 9 over 2. So basically we have plus minus 1 half, plus minus 3 halves, and plus minus 9 over 2. So plus minus 3 over 2. To figure out which of these are the actual solution, we start using factor theorem. We plug in 1 in the polynomial. If it makes the polynomial equal to 0, then it's a real 0, actual solution. If not, we try other numbers. Let us start with 1 and negative 1. If we plug in 1 in this polynomial, p of 1 would be 2 times 1 to the 3 is 2, minus 1 to the 2 is 1, minus 18 times 1 is negative 18, plus 9. Is it equal to 0? No, it's not. So we know that because p of 1 is not 0, we know that 1 is not actual solution. It was a possible solution, a possible 0, but now we know that 1 is not actual solution. So x minus 1 is not a factor for this polynomial. And we know this based on the factor theorem. Let me erase this from here because I don't need it anymore. Let's see about what happens about negative 1. If we plug in negative 1, it's not going to be 0, but let me show you. If we plug in negative 1, then we have 2 times negative 1 to the 3 is negative 2, minus negative 1 to the 2 would be minus 1, negative 18 times negative 1 would be positive 18, plus 9. Is it 0? No. So x plus 1 is not a factor for this polynomial. So we move to the next number, 3 or negative 3. Let's see what is p of 3. 2 times 3 to the 2 would be 27 times 2, 54. 3 to the 2 is 9. Minus 18 times 3 is minus 54, plus 9. It is 0. Yes, it is 0. Now we know that x minus 3 is a factor for this polynomial, which means that this can be written as x minus 3 times by another polynomial, a quadratic polynomial. To figure out what is that polynomial, we use synthetic division. Based on the synthetic division, we draw something like this. 2, negative 1, negative 18, and 9 are the coefficients of this polynomial that we have to write in here based on the synthetic division. And what number we have to write here in the left side of this? 3, because we want to divide by x minus 3, opposite sign of the number. X minus 3, opposite sign of negative 3 is 3. We have to write down here, so we put 3 here. Based on the synthetic division, this is the process of synthetic division. This is a famous method for dividing a polynomial by a binomial. We write down 2 in here. We multiply this number by this always. 2 times 3 is 6. Negative 1 plus 6 is 5. We again multiply 5 by 3. This is a repeated process. 5 times 3 is 15. Negative 18 plus 15 is 3. 3 times 3 is 9. 9 minus 3. This is minus 9. Negative 18 plus 15 is minus 3. Minus 3 times 3 is negative 9. 9 plus negative 9 is 0. As we expected. It should be 0 because this last number in the synthetic division, this last number that appears at the end always shows the remainder. And the remainder is 0 because we expected that x minus 3 to be a factor. So remainder is obviously 0. Then, what would be the polynomial that we have to write here? Based on these numbers, that polynomial is 2x to the 3, 2x to the 2, 2x to the 2, plus 5x minus 3. For factoring this quadratic function or quadratic polynomial, basically, it's better to say, we are not going to use the same method. It's easy. If you remember, The method for quadratics that we have a number here is that we multiply this 2 by this number, then we have a new number. 2 times negative 3 is negative 6. Now we look for two numbers that their product is negative 6, their sum is 5. Can you guess what are those numbers? Two numbers, their product is negative 6, the sum is 5. So here our job is this. We want to factor 2x to the 2 plus 5x plus 3 minus 3. We multiply 2 by negative 3, it's negative 6. The numbers, the two numbers that their product is negative 6 and the sum is 5 are 6 and negative 1. So we are going to write this in the form of 2x to the 2 plus 6x minus x, because the numbers are 6 and negative 1. So we write 5x in the form of 6x minus x. Here we want to do a grouping. We want to use grouping method. Then from these two we factor 2x, then we have x plus 3. From the next two we factor a negative, then we have x plus 3 again. Now attention, x plus 3 is common between these two, so we have x plus 3 times 2x minus 1. So the fully factored form of this given polynomial is this: x minus 3 times by x plus 3 times by 2x minus 1. If you are finding this factoring here a little confusing for yourself, or if you do not remember this grouping method, what you can do here, you can again repeat same process as we did here. You can check that, simply you can check that. If you plug in negative 3 here, it makes this 0, and then immediately you know that x plus 3 is the factor for this polynomial. And then by using a synthetic division, you can divide 2x to the 2 plus 5x minus 3 by x plus 3, and you can find the other factor, which is the last factor. But it is up to you. Now look at this harder example. List all possible rational roots of this polynomial and then factor this polynomial completely. 2x to the 4 minus x to the 3 minus 11x to the 2 plus 4x plus 12. First we list possible rational zeros. 12 is plus minus 1. The factors of 12 are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. What about 2? Plus minus 1 and plus minus 2. And based on this, immediately you know that all possible rational zeros are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. Now let's consider the actual rationals. 1 over 2 is a new possible rational zero. 2 over 2 is 1. 3 over 2 would be new, so 3 over 2 should be added to our list. 4 over 2 is 1, 4 over 1 is 1, 6 over all of these is 3, 6 over 2 is 3, 6 over 1 is 6, and it's in our list. Nothing new would be added, and 12 over 1 or 12 over 2 would not add anything to our list. So these are all the possible rational roots, and we listed all the possible rational roots. But which one is actual? Again, we use factor theorem to figure out which one is the actual roots. So we plug in 1. P of 1 would be 2 times 1 to the 4 is 2, minus 1 to the 3 is 1, minus 11 plus 4 plus 12. Is it 0? No, it's not 0. If you calculate, you would see that this is not equal to 0. And because it's not 0, we know that x minus 1 is not a factor for this polynomial. So immediately we check for negative 1. So let me erase this. Now we check for negative 1. If we plug in negative 1, then it would be 2 times negative 1 to the 4, which is 2. Minus negative 1 to the 3 is plus 1. Minus 11 times negative 1 to the 2, negative 1 to the 3 is 1 times negative 11 is negative 11. Minus 4 plus 12. Is this 0? 12 plus 2 plus 1 is 15, minus 11 minus 4 is 0. Yes, it is 0. And because it is 0, so it means that x plus 1 is a factor for this polynomial. So this polynomial can be written as x plus 1 times by another cubic polynomial. To find that cubic polynomial, which we don't know right now, we use synthetic division. So we draw this 2, -1, -11, 4, and 12. These are the coefficients of the given polynomial. And we have to write -1 here. Always opposite sign that is here goes here, or basically this number goes here in the synthetic division. Now for doing the synthetic division, we start. Write down the 2. 2 times -1 is -2. Add these to each other, so it's -3. Multiply -3 by -1 is 3. And -11 plus 3 is -8. -8 times -1 is 8. 4 plus 8, 12. 12 times -1 is -12, and 0, as we expected. This shows that the polynomial that was unknown to us is, yes, 2x to the 3 minus 3x to the 2 minus 8x plus 12. Why this should be cubic? Because the actual polynomial is a quartic polynomial of degree 4, is a polynomial of degree 4. When you would divide by x, it would be 1 degree less, so it would be a cubic polynomial. Now for this new cubic polynomial, we have to do same process again. So let me name this cubic polynomial here. So let me name this polynomial f, or f of x. Now I want to factor that. To figure out what are the factors of this polynomial. I know already that p of 1 is not 0. We check that 1 not makes this polynomial equal to 0. So automatically we know that 1 is not going to make this polynomial equal to 0. So we check for -1. Maybe -1 makes this polynomial 0. We have to check. Because maybe x plus 1 is a repeated factor. So you should not skip checking for -1 again for this new polynomial, which we named it f of x. Don't forget this. So we check f of -1. If we calculate f of -1, you would see that it would be -2. 2 times -1 to the 3 is -2. Minus 3 times -1 to the 2 is -3. -8 times -1 would be +8 plus 12. Is this 0? No, it's not. So we know that x plus 1 is not anymore a factor for this. So we check for the next number, which is 2. We check for 2 to see is it a factor or not. If we plug in 2 in f, then we have f of 2 equals 2 times 2 to the 3 is 16 minus 3 times 2 to the 2 is minus 12. Minus 8 times 2, we are working on this, is minus 16. And at the end we have 12. Is this 0? Yes, it is 0. So this means that, what we conclude from this? It means that x minus 2 is a factor for that polynomial. But what are the other factors? To find the other factors, again we have to use synthetic division. Yes. Because already we know x minus 2 is a factor. Let me erase x minus 2 from here. I will try to fit all of my solution in one page. So now we know that, please pay attention. Now we know that we have x plus 1 as a factor. We know that x minus 2 is another factor, but for finding other factors, we have to do synthetic division again. We write the coefficients of the polynomial 2x to the 3 minus 3x to the 2 minus 8x plus 12 here. 2 minus 3 minus 8 and 12. And what number we have to write here? Because we want to divide by x minus 2, so opposite sign of -2 is 2. We put 2 here. 2 times 2, we multiply 2 by 2, 4. -3 plus 4 is 1. 1 times 2 is 2. Negative 8 plus 2 is negative 6 times 2 is negative 12 plus 12 is 0. So we have 2x to the 2 plus 1x or x minus 6. For factoring 2x to the 2 plus x minus 6, we multiply 2 by negative 6, it would be negative 12. Then we look for two numbers that their product is negative 12, their sum is 1 or 1 because we have 1x or x, so 1. Two numbers that their product is negative 12, their sum is 1 are 4 and negative 3. So we write this as 2x to the 2 plus 4x minus 3x minus 6. Why we wrote x in the form of 4x minus 3x? Because we were looking for two numbers that their product is negative 12 and their sum is 1. Those numbers are 4 and negative 3, so 4x minus 3x. Now we do a little grouping here. We factor 2x from this, then we have x plus 2. We factor negative 3, then we have x plus 2. And then this equals to x plus 2 times 2x minus 3. So the fully factored form is x plus 1 times x minus 2 times x plus 2 times 2x minus 3. Because this is basically x plus 2 times 2x minus 3. I hope by watching this video you have learned about Rational Zero Theorem, which gives you the possible rational zeros. How we can make sure actual zeros. What are actual zeros? You start by checking these possible rational zeros with the aim of factor theorem. Then you can find the actual zeros. Then you use a synthetic division to find the other zeros. This is a process that we have to do repeatedly till we can factor a polynomial fully and we can find the possible roots. Attention, if you want to really find the possible roots, just simply set this equal to 0 and you can find the values of x. If you like this video, please subscribe in my channel. It helps the channel to grow and other people can watch more videos like this. Please subscribe in my channel and see you in the next videos.